this is another tutor. So we'll be dealing with trigonometric integrals. As you can see, this is trigonometric integrals. I'll split the video into two. So the concepts in trigonometric integrals, they are kind of long, but we'll split into two. So straight away, the concept of trigonometric integral is where you are given an integral, okay, over trigonometry and told to evaluate or find the integral of any trigonometric function. So there's a lot of concepts here, but straight away, for example, you can just go direct to an example. For example, you are told this is a trigonometric integral, so it's an integral having a trigonometry. For example, you are told integrate cos to the 3 of x dx. For example, something like that. So we have to know how to maneuver through this. So this is an odd power of cosine, okay? So I'll just have to split my cos. I'll just have to split my cos, so I'll split one cos, so I'll get cos squared. So I'll get my integral as cos squared of x multiplied by cos of 1 x dx, right? So from here, it's just a matter of thinking. So I'll just say, I want for me to eliminate cos of x, I'll have to think of a certain trigonometric function such that if I find the derivative of it, I'll get the exact thing as cos for us to be able to cancel. So for this example, as you can see, for me to eliminate cos of x, I'll have to choose my u. So I'll use u substitution. So I'll have to choose my u to be the opposite of this. Opposite of cos is just sine of x, such that if I find my derivative du, okay, I will get cos of x with respect to x, that will be dx, okay. So from there, I've chosen my u to be sine of x. So from here, I'll replace cos squared of x, okay, with that tangent identity. I have a formula. I've created a formula showing all these examples. So there's a Pythagorean identity that we say cos of x is just the same as. So we usually say cos squared of x plus sine squared of x is the same as 1. We have created a video extrapolating more on these formulas. So I'll replace my cos squared of x just the same as 1 minus sine squared of x. Okay. So in that I'll have the integral of 1 minus sine squared of x, okay, multiplied by my cos squared of x, not cos squared of x, just cos of x. But now in my dx, from here, what's my dx? My dx is du divided by cos of x. So just divide by cos of x divided by cos of x. This goes with this, so I'll get my dx as du over cos of x. So I'll get my dx as du over cos of x. Okay? So as you can see, this allows us to cancel cos of x. So I'll get my cos of x will go with cos of x. I'll get my integral from, so my integral will be 1 minus, but we said our u is sine, so this is just squared, so it will just be u squared, okay, multiplied by du. So that's easy. So from here, we'll have to integrate this. So integrating a constant with respect to du is just the same as adding a variable u. So it will just be, after me integrating this, I'll get my u minus integrating u to the square. I'll just add 1 here. I'll get u to the third divided by the result of the power. So this is my answer. Then I'll just add my constant c. Okay? So from there, I'll just replace what's my u. My u is sine of x. So my final answer, I'll get as sine of x, okay, minus 1 over 3, this 1 over 3, sine to the cubed x, sine cubed x plus c. So that's how we maneuver through that. So straight away I'll go to another example again. We'll do several examples to clarify on this. Trigonometric integrals, the concepts are long, but we'll just clear. So as we have said, we have done an example to that. So let's go to another example. Another example we have said, we are told integrate sine the 5 of x multiplied by cos squared of x dx. So how will we handle that? Again, the same procedure applies. We look, this is the odd power, this is an even power. So automatically we usually separate the odd power. Okay? So the first step is to separate an odd power, make it to be an even power. So I'll get the integral of sine to the 4th of x multiplied by sine of x multiplied by cos squared of x dx. So that's the first procedure. The second procedure, as you can see, this is sine to the 4th. So I'll just write sine squared, then I raise it to the second. So I'll get sine squared of x, then I raise it to 2. It's just the same as 4, okay? Multiply, I'll start with cos squared of x, then multiply with my sine of x dx. From the previous example, we said we wanted to eliminate, so we want to eliminate sine of x. So for us to eliminate sine of x, I'll have to choose my u to be the opposite of this, such that if I get the derivative, I'll be able to cancel that. So I'll just choose my u to be the opposite of that, will be cos of x. Okay? So my du, I'll get it as negative sine of x with respect to x, that will be dx. Okay? So from here again, the Pythagorean identity for this. So in my previous video, we had written formulas with the Pythagorean identity. So I'll just replace sine of x as sine squared of x as 1 minus cos squared of x. So my integral will be 1 minus cos squared of x. Then that whole thing, I square it, multiplied by, what is, okay, I'll just multiply by cos squared of x, okay, as you can see it's that way. Then I'll multiply by my sine squared of, I'll just multiply by my sine of x, multiplied by, what's my dx? My dx from here is just the same as, dividing this with this, I'll just, my dx now, from here, I'll get my dx as negative du over sine of x. Simple. So I'll just multiply my dx, I'll multiply by my du negative, remember, divided by sine of x. So from there, sine of x goes with sine of x. So this cancels this, okay? The negative sign, get it outside the integral, so I'll get the negative integral of, we said our u to be cos of x, okay? So this is cos to the u, so it's just 1 minus u squared, okay? Then I square that, I multiply that with my u squared, multiply by du, simple. That's how we handle that. So from there, let's expand this. So we'll have to expand u1 minus u squared. So 1 minus u squared, then I square that. Okay? So an easier way, I just take 1 squared, it will be 1. Okay? Then I'll take 2 multiplied by u squared multiplied by 1 with a negative. So I'll get minus 2u2, okay? Then I'll take my negative u squared, I'll get plus u to the fourth. Okay? So all these, just replace with that. So I'll get the integral, negative integral of 1 minus 2u squared plus u to the fourth, all that, okay, and multiplied by u squared du. Okay, so I just right here. So the concepts are easy. It's just a matter of manipulation. So from there I write, let me expand, let me open my bracket. Okay. So let me open my bracket and get negative the integral of, when I u squared, when I multiply by 1, just get u squared minus u to the second multiplied by u to the second, just u to the fourth, so it will be minus 2u to the fourth, u to the fourth. Then this multiplied by this, I'll just add to the power, so it will be plus u to the sixth du. Okay? So the concepts are easy. So let's integrate this. So you just add 1 to the power divided by the result, so you just get u to the 3 divided by 3. Okay? Again there I'll get plus 1 to the power divided by the result of the power, you just get 2 over 5 u to the 5. Okay? Plus add 1 to the power, just 1 over 7 u to the 7. Simple. Okay? But still remember the negative sign is here. Okay? So just the same as negative 1 multiplied into that. Sorry, this is supposed to be minus from here. Okay? Still negative 1 still there. So this is u to the 7th. Okay, plus a constant c. So let's multiply the negative, replacing with u to be, we said u to be cos. So let's multiply by negative, replacing our u to be that. So it will be negative, our final answer will be negative. Let me write in a black pen. It will be negative 1 over 3. 1 over 3. But what is our u? It's cos 3 of x. Then negative with the negative, it will be positive 2 over 5. Cos to the 5 of x. Negative with the positive, it will be negative 1 over 7 cos to the 7 of x plus a constant c. So that's our answer. So this is our answer. So again, we go to another example. Okay, so we'll see another example. So we are told integrate. We are told integrate. Okay, this time we have bounds from 0 to pi of sine squared of x dx. So when you are told to integrate something like this, so from here, this is an even power of sine. Okay, so we can't integrate this, so we just have to replace sine squared of x with the power reduction formula, which in my last video we saw what's the power reduction formula for this. So I'll just replace straight away. If you are not comfortable, go and check my video for that. So I'll just say the integral from 0 to pi, what's my sine squared of x, just the same as a half into 1 minus cos to the 2 theta. Okay? Oh, sorry, it's x, so I'll just place x here. So this is just the power reduction formula, dx. I had already created a video on those. So this is an even power of sine. Any even power of sine, we have to split it and use the reduction formula. So I'll get a half, that's a constant outside the integral. I'll get a half, okay, the integral from 0 to pi. So I'll have to differentiate. I have to integrate 1 minus cos to the 2x okay, dx. So this is easy. There's no need of having new substitution on what. So I'm integrating 1 with respect to x, so I just the same as adding just 1, okay? So my a half, it will be my a half multiplied by what's my, so this will just be x, so this is just the same as x raised to 0, so I'll just add 1, just the same as x, minus, how will we integrate this? This is a linear function, so you just differentiate the trig, you just integrate the trig. If you integrate cos, you get sine, so it will be sine, okay? Just write the argument the way it is, 2x, then divide it by the derivative of the argument. Divide it by the derivative of the argument. So the derivative of 2x is just 2. To be that simple, then plus a constant c. Sorry, we won't add a constant c because still we have the bounds. So this is my answer, yes. This is my answer, but we have the bound from 0 to pi. Okay? From 0 to pi. So it's that way. Remember, half multiplies throughout. So let me open a half. Let me open the a half part first. So if I open the half, I'll get a half x. Okay? I'll get a half x minus a quarter sine of 2x. Then the bound is from 0 to pi. Okay? So we usually start with replacing pi, then we minus by the replacement of 0. So the formula for reduction formula, check it on my video. So let's replace pi, so it will be a half pi minus a quarter sine of 2 pi. Okay? So let me write that. So it will be a half, replacing x with the pi, so it will be a half multiplied by pi, okay, minus a quarter multiplied by sine of 2 pi, okay, minus, replacing 0 to this, I'll get 0, replacing 0 here, sine of 0 is just 0, so to make this thing to be 0, so just minus 0, so no need, so just the same as minus 0, okay? So let's compute this. So in fact, this is our final answer. So that will be our final answer. Final answer will be that. Maybe you can do further computations on that, but that will be our final answer. Okay, so that will be our final answer. So from here, so these are expected answer, but let's compute our final answer. So our final answer it should be, from here, it's just easy, you can just see sine, the sine of any multiple of pi. Sine of any multiple of pi is usually 0, so I'll get 0 multiplied by a quarter, I'll get 0, so all this expression is 0, so I'll get a half pi minus 0. Okay, so my final answer will be just a half pi. So that's my final answer. My final answer will be a half pi. It's simple. Straight away we go to another example. So we have seen these answers just the same as a half pi. Simple, it's quite easily done. So let me try to explain something. So in my video, we saw two formulas of reduction. So in case again we are given, for example, we are told to integrate, for example, again we are told to integrate cos secant of x dx. So the same procedure applies. Replace this with the reduction formula for that. We wrote it, perform the same integration. It's just the same as the sine one, because it's an even power of cos. So let me write another example. So that's the first example as an exercise. You can compute this cos squared of x dx. Write the answers on the comment section. Again, let's compute sine to the fourth. Sine, integral of sine to the fourth of x dx. So I want to be computing, I'll just be explaining. Again, this is an even power of sine. So I'll just break down that. I'll break down that to be sine, the integral of sine. Okay? I'm breaking down into the square of x, then I square. It's just the same as I'm squaring that. Okay, let me clear that. So if I'm given any power of sine that is even, okay, my first thought, I would think it's going to be on the power reduction formula. So if I'm given sine to the fourth of x, I'll split that integral to be the integral of sine to the square root of x, then I square it, dx, right? So as you can see from here, this is sine squared of x. Okay? So I'll just compute the same procedure of sine squared of x, but I do the square. Okay? It's just the same procedure and replace sine squared of x with the reduction formula that we wrote. The same procedure, so you get your answer, right? So this is an exercise. So the exercise is 1 and 2, but this is just the same as this. So compute, write the answers on the comment section. I'm trying to be quick because the subtopic is more long. Okay, it's long. Okay, sorry. Let me just compute this. Okay. So for cos squared of x, it's just the same procedure. I replace this with the reduction formula and operate. So let me compute this. Okay. So me computing this, I'll replace my. We've said we're replacing sine squared of x with the power reduction formula. So I'll get the integral of a half into 1 minus cos 2x, okay? Then all this thing, it has been squared, dx, okay? So I'll square my half, I'll square my answer. So squaring my half, I'll get a quarter. So I'll get a quarter outside the integral. So I'll get a quarter outside the integral. So I'm remaining with this squared, so I'll be remaining with 1 minus cos 2x squared, okay, dx. So from there, let's square this. So squaring that, as you said, just square 1, it will be 1, so it will be a quarter. The integral of square 1 to be 1. Then 2 multiplied by negative of cos of this, multiplied by this, you get negative 2, that cos of 2x, right? Then I'll square this. Again. I'll get plus cos squared of 2x. I'll get cos squared of 2x. Then I'll write my dx that way. So from there, as you can see, let's start our computation. So we are integrating 1 with respect to x, automatically this will be x. Okay? And then here, again, we'll just integrate cos, we'll get sine. The argument remains the same, divided by the derivative of the argument, yes. But from here, again, this is cos squared of 2x. So this is just the same as, again, applying reduction formula to this, the cos. So we'll have to apply our reduction formula for this. So first, let's set this aside. Okay, so let's perform the integral of that. So I'll get the integral. I'll write the integral. So let's perform the cos squared of that. So I'm told to integrate. So I'll integrate. It's long, but we'll manage. Cos squared of x. The argument is 2x. Okay, dx. So this is what I'm told to integrate from here. So we'll write this cos squared of x in terms of our reduction formula, but we'll have to double our angle because again in that video we saw the double angle formulas. So we'll have to double the angle because this is 2x. Okay? If it was x alone, it could have been just the same as if it was x alone. It could have been if it was x alone, it could have been a half into 1 plus cos 2x, right? But now the argument has been twice or multiplied by 2. So again we will have to multiply this part by 2. So cos squared the 2x, I'll have to multiply that 2 again. So I'll multiply the 2 to this. So I'll get 2 multiplied by 2, I'll get 4. Okay? So that's the trick there. So instead of me integrating cos squared of 2x, I'll integrate this. So my integral, I'll replace that with this. So I'll be integrating a half 1 plus cos to the 4x dx, right? I'll take my a half. So this is the bracket. I'll take my half outside. So I'll get, taking my half outside, I'll get a half. So it's long, but it's easy. Integral of 1 plus cos of 4x dx. So integrating that, I'm integrating 1 with respect to x, is just, so I'll get just x plus, we say integrate cos, integrate the trigonometry alone. Integrating cos, we get sine. Okay? Write the argument the way it is. It will be 4x divided by the derivative of the argument. So it will be derivative of 4x is just 4. Okay? Simple. Then don't forget to place a half. A half multiplies both sides. So don't forget to multiply a half. So from here, I've performed this. So I will write this as that. So let's perform this other part. So that other part will say, so this is the integral of this part. So I'll say a quarter. Okay? Remember, a quarter is for the whole thing. So I'll say a quarter. It's for the whole thing. Okay? So if I integrate 1 with respect to x, I'll get just x. Okay? Minus 2. I'll just write minus 2. Then I'll differentiate cos. As you said, it's just sine. I'll write the argument the way it is, 2x. Then I will divide by the derivative of the argument. I'll divide it by 2. Okay? Simple. So 2 goes with 2. So it's, this just cancels with that. So I'll get x minus that. So the integral of that I'll replace with what we got. We performed it all. Just add, okay, these things. So I'll just open my bracket. So I'll just a half of x, okay, plus this multiplied by this is just 1 over 8. So it will be plus 1 over 8 of sine 4x. sine of 4x. So it's lengthy but it's good. So from there, I just multiply by a quarter throughout. So having a quarter throughout, my final answer, let me write it in a black, so I'll get a quarter multiplied, so I'll get my final answer to be a quarter x minus a quarter sine of 2x, okay, plus this multiplied by this is just 1 over 8 x. This multiplied by this is 1 over 32, so it will be 1 plus 1 over 32 sine of 4x. And remember it's integration, so we'll have to add our constant c. So that's our answer. So just write my answer. So that's my answer. So that's how we perform that integration. So from here, this is the last example we'll be doing. This is the last example we have done in trigonometric integrals. We said we'll be splitting the video into two. So I will end here. So the next video we'll be talking on the same trigonometric integrals, but different concepts now, dealing with secant and tangent, plus the product identities. So this is how you maneuver, having the formulas back in mind. So this is how you go. Remember, you use substitution and so on and so on. So do a lot of practice on this. You can WhatsApp me through my number 07. You can WhatsApp me through my number if you want more questions on that. So this is my WhatsApp number 793 634 910. Okay? So let me just write it clearly. You can WhatsApp me through that. I don't know my number. 93634 910. For some example question, you can WhatsApp that. Don't forget to like, share, subscribe. Thank you.